This particular calculus problem, we're going to find the derivative of two trigonometric functions, expressions if you like. One of them is the sine squared of 4x. The first problem, of course, is that this notation really means the sine of 4x, the entire quantity squared. So the first thing we do is the power rule, which is 2 times the function minus 1, and that gives us 2 sine of 4x. Then the derivative of the sine of 4x, which is a cosine of 4x. And then finally the derivative of 4x, which is 4. So it looks like we get 8 sine of 4x times the sine of 4x. Now we'll take Edgescape's helper that lies in our differential equations package for calculating derivatives and see what it does to us. And as you can see, considerably different form of notation because it becomes the sine of 4x raised to the second power. We scroll down and click the differential button, compute the differential, and down below we see the solution. It looks very, very close to what we did. No, it is it. So we did this intellectually and using Edgescape's helper for derivatives, and we get the same solution. Now we take the other problem, which is the sine of 4x squared, which I'm interpreting as the sine of the argument 4x squared, which is the same thing as the sine of 16x squared. Considerably different derivative. We'll scroll down a little bit and try to calculate it. It becomes the cosine of 16x squared times the derivative of the argument, which is 32x. Or 32x cosine of 16x squared. Now we'll jump back over to the derivative, see if we can put it into it, and let the helper calculate that particular derivative. This one's a little easier to put in. I'm going to put the sine of the argument, or 16x squared, and just close the parentheses. The square is just on the x. Click the differential and look down below. And guess what? We see the derivative, and it looks like 32x cosine of 16x squared. Go back over to the screen where I was doing the pencil work, and notice we get the same solution. Thank you for using one of our movies. Just a quick addition to this voice narration. I did make a mistake when I said the derivative of the first function wrong, but actually I calculated it right. Thank you.